second your comments on the last panel. And now we're going to shift into a second innovation spotlight that focuses on the scholarship and process work of Huang, who is a designer, educator, and researcher in the School of Architecture, specializing in digital fabrication, parametric design, kinetic architecture, and interactive installations. Su has longstanding interests in digitally innovative practices that come from the intersection of architectural practice and industry collaboration. As co-founder of Show Architecture, he has presented and is widely published. He's active in exhibiting his interactive installations and artwork nationally as well as internationally. So I believe, Su, he wanted to begin by sharing some comments on his work, and then will tell us when to roll his clip entitled Multi-Planar Robotic Tube Bending that captures the workflow of integrating traditionally manual techniques with industrial robotics. Su, it's wonderful to have you here today.
Thank you, Meg. Hello, everyone. As kind of Meg described, my work is sort of at the intersection of art, technology, and culture. And this is actually just a kind of peek at an in-progress design research project that is underway at the moment. I'm working collaboratively with my design partner, Gregory Spall, who teaches at the American University of Sharjah, Department of Architecture, as well as Amar Callow, who has been kind of providing support on the robotic programming side. If you can go to the next slide. And just to kind of give a sort of frame of reference, these are just some images that kind of help situate the work and the direction in which we're going. I'm bringing up the artist Sola Witt because he is one of the pioneers, both in terms of using line, the idea of a line in space and in art, and very specifically procedural art, in the sense that many of his artworks are kind of performance pieces that are actually a set of instructions, and they're just actually produced or executed by a group of teams or other people. So the parallels between that and architectural practice are very obvious. If you go to the next slide. But also more contemporary artists such as Tomás Saraceno, whose work really predominantly uses, tension and line in the creation and the framing of spatial constructs, which is very antithetical to traditional architectural practice, in which we only use the line and line weights as a form of delineation and representation in architectural drawings. But when it comes to real space, we tend to work with masses and volumes and planes, not so much lines. Next slide. So just to kind of frame that more recently, there have been a series of practitioners. In this example, Dwayne Euler and Jenny Wu of Euler Wu Collaborative out in LA, who have started kind of more predominantly using linear elements in the delineation of space in their projects. And this is kind of stuff that's been made more possible because of industrial but also computational design advancements. Next slide, please. And the sort of next other practitioner we see here, Future Forms Lab, Jason Kelly Johnson and Natalie Gattegno, their work is kind of living in between sort of interactive art as well as fabrication, but they're working really predominantly with lighting and engaging the public through these different mediums. In particular, you see the Murmur Wall at the Yerba Buena Center of Arts, and actually here in Florida, Constellation at the University of West Florida. Next slide, please. one of the things they all have in common is that they require an extensive framework infrastructure in terms of false work and scaffolding and craft and manual labor to actually execute these projects. As you can see on the bottom row, these are the screen grabs from Euler Wu's Instagram account, as well as from Future Form's website up on the top. Of course, next slide. As academics, one of the things that we start to ask is, of course, is there a better way to do these? And in terms of precedents, I think, for example, the University of Michigan, Park McDowell, Diana, and Borjana Tomova have started to look at robotic rod bending. So these are kind of solid core rods in the form of a wave pavilion. Next slide. And Maria Smiglielska, I'm butchering her name, who actually just completed her PhD at the ETH in Zurich, also looking at sort of robotically bended, kind of means of fabrication in this case. Next slide. And another sort of more cultural framework or background where a lot of this research actually started originating is actually from a design build studio that my partner was part of at the American University of Sharjah, actually really looking at lightweight structures, and they were working in a zone in Sharjah called the Rub al Khali, or the empty quarter, which is a part of a giant desert that's completely isolated. It's described as one of the most isolated places on Earth. And the preservation of that desert, but also the nomadic Bedouin tribe that lives there and their lightweight shelters that they carry around. And the students were kind of using manual bending techniques to design and fabricate some of these moving shelters. What's going to come here next is a sort of audio and visual collage of sorts of our sort of ongoing project. And the volume you might be a little loud, so that might need to be adjusted. But next slide. So hopefully this stream looks not too choppy, but this is a KUKA 125 industrial robot. It has a payload of 125 kilograms, spatial repeatability of 0.2 millimeters. What you see is the 3D printed kind of grip that we fabricated to fit with the pipes that we are bending. It's connected to a pneumatic sort of positioner. This is the turntable that actually does the bending with this forming. And these are just kind of examples of early tests. Of course, to kind of pin down the material kind of behavior, we had to do a bunch of tests and index the material stream back using linear regression methods to be able to more accurately predict the performance of the pipe when bending it at different degrees. Now we're using a software called KUKA PRC. It is a plugin for Rhino and Grasshopper that allows us to simulate the robotic kind of bending sort of process. And this is the sort of prototype that we created. It is a coffee table that uses pentagonal rotational symmetry. And it creates these elements that essentially the accuracy is precise enough through the bending process that we are able to basically kind of draw these lines in space, fabricate them, and have them meet each other right on the different opposite ends very precisely. Thank you for turning down the volume. And you can see this is the process of bending one of those pieces of the leg of that coffee table, just as a sort of exercise and kind of testing the capabilities of it. It's sped up at 2 times the speed, but even so, you kind of see the process of fabricating that element is really quick. Of course, we're still using manual methods at the moment to cut the piece, but eventually that's something we want to work on and automate. What you're seeing here is a little bit the back end of the visual programming part of Grasshopper. the code that we assembled to take a simple curve and turn it into the robot code, the KUKA KRL code for the robotic programming and for the robot to run. But it also allows us to implement collision detection as well as the instruction sets for kind of opening, closing the grip as well as the turntable. This third prototype you see is also kind of expanding on that, but now we're actually making more complex frameworks and structures. It is one continuous loop so each color you see here is actually one continuous line just woven together. And that's the first kind of material prototype. It's been actually accepted to the Ras Al Khaimah Fine Arts Festival in Abu Dhabi. I'm also working on a very preliminary here, a generic algorithm method of kind of determining the perfect kind of breakpoints for segmenting it. Some of these proposals continue to our previous work, and what that proposal you just saw was actually shortlisted for the 2021 Seoul Biennale in Architecture. And we're kind of working on it at the moment. But we're also linking this to a lot of our previous work that lives in the realm of interactive architecture or interactive installations, basically kind of combining some of this more physical space frame-like fabrication with some of these interactive and lighting elements that react to human occupation. Next slide. So there are just some future challenges. I won't go through this, one by one, but collision detection, trying to kind of develop and integrate morphological rule sets that inform some of the design parameters, particularly in relationship to the minimum distance necessary between bends because of the distance of the forming pin. Looking into more flexible setups that is able to deal with different diameters and compound curvature or non-uniform radii. As well as precision and construction tolerances, particularly tolerance creep. And there is a sort of group called Hologram who's using the Microsoft HoloLens as a way of kind of being able to visualize and position things spatially in real time and be able to adjust on the construction site. And finally, of course, joinery is always somewhat of a tricky kind of issue that we're working on at the moment. Next slide. This is probably just a couple of references from material that I referenced earlier. And then finally, next slide, are some acknowledgements. Essentially myself, my partner, Gregory Spa, Amar Callow, and Patrick Rhodes, who actually is a UF graduate. He's alumni, and he's teaching there as well. He was the sort of first person who kind of started the design build studio that started kind of looking at some of these things. And that's it. Thank you.
Thank you so much, Professor. That was really amazing.